Hi, I am Tanmay Parekh and I am presenting this joint work with Amrith Setlur, Aman Madaan, and my other colleagues at Carnegie Mellon University. Our work introduces a new task for politeness transfer and correspondingly a new style transfer pipeline, tag, and generate. Very briefly discussing the structure of our presentation, we divided into three major sections. First, we introduce the task of politeness transfer, then we talk about our proposed methodology, and finally discuss our experiments and results. So starting with the problem statement then, a simple one-line description of the problem statement would be converting non-polite sentences to polite sentences while preserving the meaning. Consider the example send me the data, which can be made more polite by restructuring it as could you please send me the data. Politeness transfer will be a useful task and has many widespread applications like drafting or correcting email responses, personalizing chatbots, and further in the education sector. We begin by discussing some challenges associated with this task. The first challenge being that politeness is culturally diverse and does not have a universally accepted definition. For example, a sentence like, could you please open the door, which is commonly polite in North America, could be awkward, if not rude, in the Arab culture. Next, we discuss how politeness on the surface, even though it looks obvious, is not so obvious and it is much more subtle. Like common examples include please, sorry, and thank you, but there are much more subtle gestures like hey and greetings or being indirect or using first person plural like us. Thus, we can't build a simple rule based model to add please and thank you to make the sentences more polite, and we need much bigger and complicated models to capture this subtleties of politeness. Another challenge is how the non-polite class is ill-defined and not so apparent. Let's look at some examples here. We observe that by adding some phrases helps to convert non-polite sentences to polite sentences, and how such phrases help in easy identification of polite sentences. But a key point is their absence does not as clearly indicate that a sentence is non-polite. It is difficult to objectify the absence of politeness. Finally, speaking from a perspective of a machine learning researcher, the biggest issue is the lack of any label data. The scope of a task is huge, and here we narrow down our focus in this work. From a linguistic standpoint, there are many issues concerning diversity and the definition of politeness. And in our work, we restrict ourselves to the definition of politeness accepted by North American English speakers in a formal setting. For the same, we stick closely to the definition in Christian's paper. The other end of the spectrum of politeness is the impolite class, which majorly consists of insulting phrases and curse words. Although challenging, we still restrict our focus in this work to the more interesting task of converting non polite sentences to polite sentences and do not consider impolite sentences in our domain. Diving deeper into the task, we understand that not all sentences can be made polite. Consider a factual sentence like the earth revolves around the sun. How do we make this more polite? Thus, in our work, we narrowed a set of non-polite sentences to sentences consisting of requests or action directives, as Girafsky puts it. And we focus on converting these sentences to polite sentences.
Hi, I'm Amrith, and now we shall describe our proposed approach. We begin by describing certain characteristics that we expect to observe in the final output. Firstly, we expect to see attribute markers indicative of the target style. For example, in the case of politeness, we may observe phrases like could it be possible or would you please. On the other hand, for sentiment transfer, terms like okay and bland, which correspond to a negative source, are replaced with terms like great and delicious in the generated output. The second desirable characteristic is content retention, something which our approach is positioned to handle explicitly. Sentences in the source style broadly consist of content and attribute markers, and we wish to retain as much content as possible by replacing these attribute markers with tag tokens and retaining the rest of the sentence as is. As we can see here in the example, the phrase "send me the data" contains all the originally intended communication, and the tag token can now be replaced with appropriate phrases to generate a polite sentence. Our tag and generate pipeline consists of two phases. The first phase involves the tagger model, and there are two types of tagger: add tagger and replace tagger. Add tagger adds tag tokens at appropriate locations in the input, denoted by the random variable x in the figure, to render an interpretable style-free sentence, denoted by z of x. And this is designed specifically for tasks like politeness transfer, where the source sentences are usually style-neutral and devoid of any noticeable attribute markers. On the other hand, replace tagger replaces source attributes with tag tokens. This is more useful for tasks like gender and sentiment transfer. The second phase is carried out by the generator module, and it involves filling the tag tokens with contextual attribute markers in the target style. As we can see in the second example, the intermediate style-free phrase "the chips are tagged" has now been replaced with "the chips are great." Both tagger and generator can be viewed as sequence-to-sequence models, and these can be trained using aligned pairs of sentences that we shall create from originally unaligned corpora in the source and target styles. We shall now briefly describe the training data creation process for each of the two modules. Beginning with add tagger, step 1 of training data creation involves removing attribute markers. As we can see in the figure, the attribute markers OK, bland, and terrible have been replaced with blanks. Step 2 now involves filling in these blanks with positional tags. By positional tags, we mean that each tag token is appended with a number like tag 1, tag 2, tag 3, and so on, which is indicative of the location in the original sentence. For example, tag 1 is likely to appear in the beginning, and tag 7 or tag 8 is more likely to appear in the end of the sentence. Finally, for generator, the training data is created by taking as input the sentences from the target corpus, and these are riddled with positional tags. The output would then be the completed sentence available from the target's corpus, thus creating an aligned pair, one with the tags and one with the attribute markers from the target style. The positional tags help the generator to learn a different distribution over the inserted phrases for different locations in the sentence. For example, one is more likely to begin a polite sentence with a phrase like "would you please" or "could you," and more likely to end it with a phrase like "sorry" or "thank you."
So we have looked at the problem statement and the proposed methodology. Now let's look at the experiments and results and see how our system performs as compared to the baselines. The first metric we look at is accuracy, which tells us the percentage of outputs that were polite as generated by each of these systems. As we can see, most of the systems do fairly well on accuracy, with the exception of BST. Interestingly, CAE does really well, getting an accuracy of about 100%. Now, to put this number into perspective, we need to note that the classifier really is only looking for keywords and phrases that can indicate politeness. So, if we had a system that generates "please," "thank you," "kindly" for any given input, such a system would get an accuracy of about 100%. This indicates that we need to use metrics that also look at content preservation. The first such metric that we use for these purposes is blue. As we can see, our system outperforms all the baselines on blue, getting a blue score of about 70, and the next best system, DRG, gets a blue score of about 15. We also evaluate our system on two more content preservation metrics, Meteor and Rouge, and for both these metrics, our system outperforms all the baselines. We do have results on other data sets like Yelp reviews, political slants, Amazon reviews, captions, and gender in the paper. We performed human evaluation as well on three different metrics: content preservation, grammaticality, and attribute match. As we can see, our system outperforms the next best system, DRG, on all these three metrics. We note that we did not perform human evaluation for attribute match on gender and political datasets because these judgments are prone to personal biases. Now we go through some qualitative examples. So we show an input, we'll show the corresponding output generated by our system, and we'll highlight the politeness strategy at play. The first input is what happened to my personal station, and the system generates "could you please let me know what happened to my personal station?" And the strategy at play here is counterfactual modal, which involves adding phrases like "could you," "would you" to sound less direct. The next input is yes, we can go ahead and remove it. And the system generates yes, we can go ahead and remove it. This is called first person plural, whereas phrases like we are used to indicate collective responsibility. The next input is not yet, I'll try this weekend, is converted to sorry, not yet, I'll try to make sure this week. And this strategy is apologizing, which involves adding an apology in sentences that indicate a failure. We note that content preservation is not perfect in this case. The next input is please check on Metro Media Energy, and the output is please check on Metro Media Energy, thanks. So in this case, the system adds a thanks at the end, mitigating the so-called please start. In summary, we introduce the task of politeness transfer, and we release a dataset to promote further research on this topic. We propose a two-stage approach, tag and generate, that can perform interpretable style transfer. Both automatic and human evaluation shows that our system outperforms all the baselines on